So let us start DPCM transmitter. Now the DPCM transmitter is a very simple device. How it will work? Let us discuss. We will know that all how a transmitter work. But first we have to know that in DPCM we transfer the differences between consecutive samples. That means, let us suppose our first sample is mk. Let our second sample is m of k plus 1, and third sample is m of k plus 2, and let fourth sample is m of k plus 3, and so on. Now as this is the first sample, let us suppose that there is no sample before first sample, so let us consider it 0. Now the first we have to transmit the difference between the mk and 0. That means first difference will be nothing but mk minus 0 and its equivalent value of dk. Then dk plus 1, it will be mk plus 1 minus mk. And the second difference will be d of k plus 2, which is m of k plus 2 minus m of k plus 1. Similarly, the third difference will be third for dk plus 3. You can say fourth difference will be m of k plus 3 minus m of k plus 2. Now come to the block diagram of transmitter. Now let us suppose first we have mk and we have to transmit the first difference, which is mk minus 0. So that is plus and this is minus. Okay, this is d of k, first difference, which is nothing but mk minus 0. Now we have to quantize this value with the help of quantizer. Quantizer will give the equivalent of dk, which is nothing but dqk. Now the first difference which we have to transmit is dqk. Okay then, so dqk is now available at the output of the transmitter. Now how can we calculate the next difference for the next sample? So for this purpose we will add this 0 with the present dqk plus, and here we will get dqk plus 0, which is nothing but mqk. Now it goes inside to the predictor. Predictor is a special circuit or device, you can say. It is actually transversal filter, and the working of predictor I will describe it further. Now predictor output will be the approximated value of mqk, and it will be m of qk, and it goes this at this point, and definitely the next value after 0 will be mqk. It is ready for the next clock, and the next after next clock pulse the input will change to m of k plus 1. Now at this point the difference will be dk plus 1. Okay, then dk plus 1 will be m of k plus 1 minus mq k. Now at this point, this will again come to this point. So the second sample will be now quantizer will quantize dk plus 1, and the next difference will be available at the output of the transmitter, which will be dqk plus 1. Okay, now dqk plus 1 at this point, dqk plus 1, this is dqk plus 1, sorry. Now dqk plus 1 plus mq and k. Now at this point, we have dqk plus 1, which is nothing but this one, because dqk plus 1 is the quantized value of dk plus 1. So we will have mqk plus 1 minus mqk and plus mqk. So these two values will be cancelled out. Now the output of the predictor, the next value will be mqk plus 1, and its approximated value. Now at this point, this value will be available at this point. Now the next sample value for the next clock pulse, after the next clock pulse, there will be mk plus 2, which is available at this point. And at this point again the value will be dk plus 2, and this value will be equal to mk plus 2 minus mqk plus 1, mqk plus 1, this one. At this point value will be mqk plus 1, and at this point it will be transmitted as dqk plus 2. Now the next value will be dqk plus 2. So again at this point it will be mqk plus 2 minus mqk plus 1 minus mqk plus 1, and this value will be cancelled out. So the next point which is available for the negative terminal of this subtractor will be mqk plus 2 and its value, approximated value. Now at this point, when this value will come to this point, the next sample will change to mk plus 3, and the procedure of this approximation of the calculation of the output will continue. So at this, for this point, so value will be dk plus 3, and it will be mk plus 3 minus mq, estimation value k plus 2, and value will be 3, and here the value will be dk plus 3 again, and the point will be, okay, I think you already know what will be the output at this point. It will be mq k plus 3, and this is not like this, this is mq, and at this point for the next pulse, clock pulse, our output will be this. So the next difference will be dq k plus 3. Now these are the transmitted differences towards the receiver. Now we will study how the DPCM receiver is working. Now consider this figure. First, what are we receiving? is the first difference, which is nothing but dqk. So this is dqk, which is available at the input of the receiver, and this point, this is again. Now at this point, what will happen? We have to add the previous value at this dqk with the previous one. So let us suppose that previous value is 0, then the output will be 0 plus dqk, and that will be nothing, will be mqk. Okay. As there the first sample is nothing but mk, so this value will be mqk. Now this is available at the output. Now this value again goes inside to a predictor. Okay, and the value is mq. This is k. After predictor, it will be the approximated mqk. Now the next difference will be d of q, k plus 1. Okay, and at this point it will be mqk plus dq k plus 1, which will give you mq k plus 1. So previously what we have already received, it was mk, and the next sample we are receiving is mk plus 1. Okay, then this now at this point value is mqk plus 1. So this is the predictor will give the estimated value, which will be mq, approximated value of quantized value, and here the difference will change to dq k plus 2. Now at the output of this summer, now we will receive dq k plus 2 plus m q k plus 1, which is nothing but mq k plus 2, as dq k plus 2 is the difference between the two consecutive samples. So when you add this value with mq k plus 1, you will definitely get the next sample value. So next sample will be mq k plus 2, and this circuit this block diagram will the procedure of this work procedure, or you can say the work of this receiver will go on continuously as the sample comes. The difference will come at the input to this receiver. It will generate the consecutive samples. So this is the receiver of DPCM, and this is nothing but the transmitter. So this is the transmitter of DPCM. Thank you.